In 1955, America switched on the most powerful forging press on Earth. Its foundations went 100 feet into bedrock, and for the next 63 years, nothing built in North America would come close to it. Then, one spring morning in Sichuan, a Chinese machine closed on a glowing block of metal, and the world record quietly changed hands. To understand why that matters, you have to understand what a forging press actually is. Because it is not a factory tool in any ordinary sense. It is a piece of national infrastructure disguised as a machine. When you heat a block of aluminum or titanium until it glows and then squeeze it, slowly, with enormous force, the crystal grains inside the metal stretch and align. They follow the shape of the part. A forged component is not simply a piece of metal cut into a shape. It is a piece of metal whose internal structure has been rearranged to survive the loads it will carry. That is why the landing gear of an airliner is forged and not machined from a slab. That is why the bulkheads that hold a fighter jet together are forged. Casting is cheaper. Machining is more flexible. Forging is stronger. And when a part has to hold 100 tons of aircraft dropping onto a runway thousands of times for 30 years, stronger is the only word that counts. Here is the cruel arithmetic behind it. The force you need rises with the area of the part you are pressing. Double the size of the forging, and you need roughly 4 times the force. So a country that owns a bigger press is not merely making bigger parts. It is making parts that no one else can make in one single piece. Everyone else has to take that same structure, cut it into 3 or 4 smaller forgings and bolt them together. The bolted assembly is heavier. It has more joints. Every joint is a place where a crack can start. In aviation, the press you own quietly determines the aircraft you are allowed to design. The Americans learned this lesson the hard way, and they learned it from the Germans. When Allied technical teams moved into German industrial plants at the end of the Second World War, they found something that unsettled them. German engineers had been forging complex aircraft parts in magnesium and aluminum on presses far larger than anything the Allies had. The largest German machine was rated at roughly 30,000 tons. Nothing in Britain or the United States came close. The American teams dismantled 2 German presses in the 15 to 16,000 ton class and shipped them home. The biggest one, the 30,000 ton machine, ended up in Soviet hands. Reports circulated that drawings for an even larger German press, one in the 55,000 ton class, had gone east as well. For Washington, that was not an industrial footnote. That was a strategic emergency. Jet aircraft were arriving. Supersonic flight was arriving. And in the calculation of the late 1940s, the Soviet Union had just inherited the ability to press aircraft structures that American industry physically could not make. The response became one of the strangest and most expensive industrial projects in American history. Planning began in the closing months of the war. Air Force Lieutenant General Kenneth Wolfe pushed it through the bureaucracy, and by around 1950 it was moving with real money behind it. The original vision called for 17 machines at an estimated cost of $389 million. In 1953, the plan was cut back to 10 machines. When it finally ended in 1957, it had delivered 4 enormous forging presses and 6 extrusion presses at a total cost of $279 million. In the money of that era, that was an extraordinary sum to spend on machinery, for which, as the planners openly admitted, no commercial market yet existed. The government paid for the machines, then handed them to private industry to run. 2 of those machines were the giants. Both were rated at 50,000 tons. One was authorized for Cleveland, Ohio in 1952 built by the Mesta Machine Company of Pittsburgh, installed inside a government facility next to an Aluminum Company of America plant on Harvard Avenue. The other was built by Loewy at Wyman Gordon in North Grafton, Massachusetts. The numbers behind them still sound unreasonable today. The Cleveland Press stands 87 feet tall, and only 51 of those feet are above the shop floor. The other 36 feet are underground. The whole machine weighs roughly 8,000 tons. Its die table measures 12 feet wide by 26 feet long. The opening between the upper and lower dies is 15 feet. It rides on 8 alloy steel columns, and each of those columns began life as a 270-ton ingot, was finished to 40 inches in diameter and 76 feet in length, and then had an 8-inch core drilled out along its entire length, so that engineers could inspect the metal at the very center of the column. 8 main cylinders, each 60 inches across, drive it. The hydraulic system runs at 4,500 pounds per square inch and moves nearly 12,000 gallons a minute at high pressure. There are 23 major control valves, and some of them weigh as much as 12 tons apiece. The Massachusetts press was built to the same brutal scale. It took 4 years to build. It contains around 25,000 individual parts. Its foundations descend 100 feet into bedrock. It stands 10 stories high with 48 feet above the shop floor. Its die table can carry pairs of dies weighing up to 50 tons, and the working surface is large enough to park 4 cars on. In October of 1955, it made its first forging, a landing gear support rib for the Lockheed Super Constellation. Think about the force involved. The engineers who documented the Cleveland machine described its output this way. At full pressure, spread across the entire die bed, it is the equivalent of standing a solid steel ingot 612 feet high on top of the part. That is a column of steel taller than most skyscrapers of the era pressing down on a single glowing piece of aluminum. And it worked. Those machines did not just set records, they rewrote what American aerospace could build. The Massachusetts press produced the main landing gear beams for the Boeing 747, each one 20 feet long, 4 feet wide, weighing more than 4,000 pounds, forged in titanium. More than 2,000 of them were made, and according to the company's own record, not one was rejected. The same machines made wing spars, rotor hubs, fuselage bulkheads, and structural sections for military aircraft. Every wide-body airliner, every fighter, every helicopter of the American era passed, in some form, through the shadow of those presses. Then something happened that almost nobody noticed at the time. America stopped. The heavy press program ended in 1957. And after that, for the rest of the 20th century, the United States did not build a bigger forging press. Not one. The machines of 1955 simply stayed the largest in North America, decade after decade, through the moon landings, through the jet age, through the entire Cold War. In 1982, the federal government sold the Massachusetts plant to Wyman Gordon and the Cleveland plant to Aluminum Company of America, which had been operating it since the beginning. The record holders became private property. They were still the biggest presses on the continent. They still are, with one exception we will come to. Meanwhile, the rest of the world did not stand still. The Soviet Union, holding the German machine and the German know-how, built 2 presses rated at 75,000 tons. One at Samara and one at Verkhnaya Salda, machines standing around 35 meters tall. Then something quietly humiliating happened for Western industry. When France decided it needed a giant press of its own for its aerospace sector, it bought one from the Soviets. A 65,000-ton machine, built by the Soviet Heavy Machinery Works, Installed at Issoire in central France in the mid-1970s, where it still forges structures for Airbus and Boeing aircraft to this day. A North Atlantic Treaty Organization member buying its most strategic industrial machine from the other side of the Iron Curtain because nobody in the West was building at that scale anymore. And there is one more piece of timing that makes the American plateau look even stranger. In the very same year that China broke the record, Japan finally joined the small club of nations able to press at this scale, commissioning a machine rated at 50,000 metric tons, which, once you convert the units honestly, actually edged past the American pair. Which means that in 2013, one Asian country quietly overtook a 1955 American record, and another Asian country shattered it outright. And both events happened barely a year after the American record holder itself had crawled back out of 4 years of emergency repairs. By the 2000s, the American giants were showing their age. In 2008, cracks were discovered in the Cleveland press, and it was shut down. The repair was originally estimated at $68 million. By the time the machine came back into service in early 2012, the total had reached about $100 million. For 4 years, one of the 2 largest presses in the Western Hemisphere sat silent, being rebuilt at a price that would have bought a substantial new machine outright. And it was during exactly those years, while America was repairing a machine from 1955, that China was building something else entirely. Until then, China had nothing in this league. Every die forging press in the country was rated below 40,000 tons. That single fact shaped everything about Chinese aviation. Without heavy presses, you cannot forge large single-piece structures. Without large single-piece structures, your aircraft carry more joints, more fasteners, more weight, and more inspection burden. Chinese engineers understood the constraint perfectly. They had been living inside it for decades. The company that decided to break it was, on paper, an unlikely candidate. China National Aircong Group sits in Dayang, in Sichuan Province, hundreds of kilometers inland. Its origins go back to 1958, when workers were moved out of China's industrial northeast and deep inland onto the plains of the southwest to build artillery and heavy equipment far from the coast and far from any likely front line. It was a child of the great heavy industry push of that era, and of a strategic instinct that has never really left Chinese planning. Put the things you cannot afford to lose where they are hardest to reach. Over the following decades, it grew into a producer of steel mill equipment, nuclear power components, and ship parts. At its height, it employed around 13,000 people and supported roughly 10,000 retirees. In an inland Chinese city, a company like that is not an employer. It is the city, and Aircong built the machine. On the 10th of April, 2013, the 80,000-ton die forging press at Dayang completed successful trial production. The specifications are worth hearing slowly. The machine stands 42 meters tall. It weighs approximately 22,000 tons. Its working platform measures 4,000 millimeters by 8,000 millimeters, which was described at the time as the largest in the world. Its synchronization precision is quoted at 1/100th of a millimeter per meter, meaning that across a platform the size of a small apartment, the press stays level to within the thickness of a human hair. It can forge at any tonnage on the way up to its full 80,000-ton rating, which matters enormously, because a press that can only slam at full force is a press that destroys as many parts as it makes. And the first piece it pressed in that trial was not a test billet or a symbolic slab. It was a large forging for the landing gear of a domestic Chinese commercial airliner, the program that would become the C919, China's answer to the narrow-body jets of Boeing and Airbus. The first thing the largest press in the world ever made was the leg that would hold a Chinese passenger jet off the runway. Now, about the second half of that headline, did China tell nobody? Not exactly, and the truth is more interesting than the myth. China announced it. The Ministry of Science and Technology published the result. Xinhua carried it. The Chinese defense and industrial press celebrated it loudly, with the specific pride of a country that had just taken a world record away from the United States, Russia, and France in a category those three had monopolized since the 1950s. Inside China, this was a national event. Outside China, it was almost nothing. There was no significant coverage in the Western general press. No cover story, no congressional hearing. A handful of trade publications and a scattering of engineering forums noticed, and that gap between how loudly it was announced and how quietly it landed is the real story. It was not a secret. It was simply not interesting to the people who should have found it most interesting. In 2013, the Western industrial conversation about China was still overwhelmingly about cheap labor, consumer goods, and assembly. The idea that a company in inland Sichuan had just built the most powerful forging press in human history did not fit the story people were telling themselves. So it slid past. Which brings us to the claim in the title, and to the part where honesty matters more than drama. Is the Chinese press 4 times bigger than the American one? Measured machine against machine, no. Let us do it properly. The American presses are rated at 50,000 tons, and that is the American short ton, which works out to roughly 45,000 tons of force. The Chinese press is rated at 80,000 metric tons, which is roughly 88,000 American short tons. So, in raw force, the Chinese machine is about 1 3/4 times the American record. Not 4. By total mass, the gap is wider, 8,000 American short tons of machine, which is about 7,250 tons, against 22,000 tons of Chinese machine. That is almost exactly 3 times. By height, 42 meters against about 27. A little over 1.5 times. And here is the detail almost nobody mentions. The working tables are nearly the same size. 12 feet by 26 feet in Cleveland is about 29 square meters. 4 meters by 8 meters in Dayong is 32 square meters. Practically identical. The Chinese machine is not pressing a much larger area. It is pressing a similar area far, far harder. So where does 4 times become real? Not in a single machine, in a national build-out. Because China did not stop at Dayong. In Xi'an, a company called Triangle Defense operates a 40,000-ton class press and has become the dominant supplier of large structural forgings for China's newest military aircraft, holding more than half of that market. It supplies structures for the C919. It makes turbine discs and blades, and it partners with Siemens Energy on gas turbine components. And on the 24th of October, 2024, ground was broken at the Xi'an Aviation Base on something that dwarfs everything discussed so far. A multi-directional die forging press rated at 125,000 tons. 110,000 tons of vertical force, plus 12,500 tons applied horizontally, so the machine can squeeze apart from more than one direction at once and produce shapes that a simple up and down press cannot. Completion is targeted for the end of 2026. That is now. That is months away. When that machine runs, it will be roughly 2 3/4 times the force of America's 1955 record in one press. And the aviation park it sits in is planned to reach a total forging capacity of around 230,000 tons, with annual output projected above 5 billion yuan. Set that park against the single American machine that defined the world for 6 decades, and you are passed 4 times, comfortably. But there is a twist in this story, and leaving it out would make the whole thing a lie. The 80,000-ton press very nearly destroyed the company that built it. Erzhong lost about $40 million in 2011. Over the following 4 years, it accumulated losses in the region of $2 billion. The press, the crown jewel, the world record, sat largely idle. Critics inside and outside the company argued it had been built despite serious internal doubts about whether there was enough demand to justify it, and that its control systems leaned on older Russian design thinking rather than the newest technology. Barely 3 months after the press completed its trial production in July of 2013, the state quietly transferred Erzhong into Sinomac, a much larger state machinery group, in a rescue that pointedly did not involve simply handing over cash. It was not enough. In September of 2015, Erzhong warned publicly that it might default on its debt, and workers protested when management proposed voluntary layoffs with severance terms they considered insulting. So, the world's most powerful machine was, for a while, a monument to overinvestment, a textbook example of what economists were then calling China's zombie firms kept alive by lending, rather than by demand. Both things are true at once. It was a genuine engineering triumph, and it was a financial disaster. Anyone who tells you only one half of that is selling you something. And America did eventually respond, though not in the way you might expect. On the 23rd of October, 2018, a new press was unveiled at Paramount, California, at a company called Weber Metals. 60,000 tons, $180 million of investment, with $20 million in California tax credits. Nearly 10 stories tall, with 2/3 of the machine below ground. The world's largest pull-down forging press, designed so that the moving parts pull downward rather than push, which changes how the machine handles enormous loads. It forges large single-piece titanium and aluminum structures, including landing gear beams for the Boeing 737 MAX. Weber expected the project to roughly double its workforce, to around 800 people. It was the first time in more than 60 years that the United States had a forging press larger than the ones from 1955. And here is the detail that says everything about how the industrial world shifted. The company is owned by a German firm, Otto Fuchs, and the press itself was supplied by German press builders. America's answer to losing the record was built with German capital and German engineering on American soil, which returns us to where this began in 1945, with American teams standing inside German factories, staring at machines they could not match, and deciding that a nation which cannot press its own metal cannot defend itself. 80 years later, the same logic is playing out again, with the roles rearranged. The presses of 1955 are still running. The Cleveland machine, rebuilt at a cost approaching the price of a new one, is still forging parts for aircraft that had not been imagined when it was poured into the ground. The Massachusetts machine is still working. They are magnificent, and they are museum pieces that happen to still have a job. The difference is what happens next. America built its giants once in a burst of Cold War fear, and then treated the capability as a finished achievement, something to maintain rather than extend. For 63 years, that assumption held, mostly because almost nobody in the West was building at that scale anymore. China treated the same capability as a starting point, took the record in 2013, nearly bankrupted the company that took it, kept building anyway, and is now weeks or months from switching on a machine that makes the 80,000-ton press look like an intermediate step. Nobody wins a war with a forging press. But every large aircraft, every heavy landing gear, every turbine disc, every hull component and rocket structure that a country wants to build in one piece rather than three runs through a machine like this. It is the quietest kind of power there is. No launch ceremony reaches the evening news. No headline is written when a press in Sichuan closes on a piece of hot titanium, which is exactly why, when the record changed hands in 2013, almost nobody outside China noticed. The announcement was made. It simply was not heard. And the most consequential industrial shifts almost never announce themselves twice.